Hello Internet, this is JF, and I suck at ATS. What you're looking at is the wreckage of a much longer video about Idris, basically. It's a bunch of Idris code, and I just went through and I wrote it in ATS. And when it started to get interesting is also when the video kind of broke down. So this is what instead of talking about Idris, I'm going to talk about this specific issue. It's good to know. It's good for me to know, especially. So what it broke down is at this myvect type. So myvect is just a list. It's a list that's refined by type. So it's a myvect of ints or strings, or whatever. Also by an int, which is the length. So if it's an empty list, then an empty myvect, then of course it's 0. If there's a constructor, then it has whatever type. Also empty has whatever type. It's a constructor that has whatever type. And then it has it's a length of whatever n, and it contains an n minus 1 vect. So if you have a myvect of 5 n's, say, then there's going to be a myvect of 4 n's that's contained within it, and then a myvect of 3, 2, 1, eventually get down to empty. So this, what I just described to you is logical, like that's how lists work. But ATS apparently allows for the possibility that it doesn't work like that. So you need to kind of prove it or just assert it in cases. So, for example, if you have like this right here, I have like I have a pattern match. So I'm saying, okay, I'm going to construct something, and then I'm going to pattern match what I constructed against. If it doesn't equal that, then give me a runtime error. So if I change this to 2 and I compile this and run it, if it actually worked, then it would give me a runtime error here because it's not actually 2, it's a 1. In the same case, if the structure weren't the same. You wouldn't do this in like a real program, but for the kind of thing I was doing, like a bunch of random code and then testing to make sure it worked, like, yeah, let's implement even and let's make sure that works. This is the sort of this is actually pretty convenient. It's very similar to what you would do in like a REPL in another language. So anyway, since ATS allows for this to not be the case, that this thing is actually n minus 1, then you give it things like, okay, it's a cons of when you're constructing something, you can say it's like a cons of, just guess the type, figure the type out, and it's 3. So I'm creating a myvect 3, which is it has 3 elements. So 1, 2, and 42 in this case. So that kind of. Sorry, I'm getting over the trauma. That's the case. So yeah, you just have to tell it because it can't figure it out. But it also can't figure it out here. So this is a length function. You can pass it a myvect of some type and some length, and then it returns an int that has to be the same length. You do normal pattern matching. Say, is it empty? If it's empty, then 0. If it's a constructor, then 1 plus the length of the rest of the thing. So basically, we were just talking about like we're not being clever here. We're not being we're not using an accumulator or not. There's normal code, but this normal code does not work. So let's look at this error here. There's a constraint failure involving like greater than or equal to of something. So it's a greater than equal to of 0. So something is not greater than equal to 0. And that something involves subint event, so a subtraction of n and 1. It also tells you the errors on 93 and 37. So line 93 here, 37, it's this. It's complaining about this. And then if you remember the constraint failure, it's saying, hey, this n minus 1, I don't think that's greater than or equal to 0. Because what if n were 0? If n were 0, then n minus 1 would be negative 1, which is definitely not greater than or equal to 0. So, how do you resolve that? Well, one way to resolve that is you say, okay, fine. No, actually, there's one way to resolve it, I think. I wonder if you can actually do this. I tested a bunch of stuff. I didn't actually test this. Can I say it is greater than 0? It's not a natural number now. It's greater than 0 in that case. Oh my god, that works. Oh. Okay, so that's one way to do it. But I struggled for like 20 minutes over this, and ended up bailing on the video I was doing. And I looked in like the ATS's own libraries, like listvt has like a proof function that it uses instead, because it doesn't do this. It doesn't say, oh yeah, in has to be greater than 0 if you got a constructor. Like obviously, if it's a constructor, it's greater than. This makes so much sense. I was like really irritated with this, but it makes complete sense now. I wonder if I can I remove that? I bet I can't, but yeah, you still can't do that. You still have to tell it that. That's something you wouldn't normally run into because you'd use like either like a list syntax, or you're in a function. Like you're in a function, you don't have to deal with like saying this is actually a list of 3 elements or something. So don't mind that. I don't mind that so much. But this length function not working was driving me nuts. Okay, so if you run into this, you could of course be not you could just not tell it that it's greater than or equal to 0, because then it's going to complain. It's like, hey, if n can be 0, and then n minus 1 can be negative 0, then can be less than 0, and that doesn't fit. That doesn't fit what you're telling me. So it'll complain. Oh my god. All right, so let's pretend we didn't make the discovery and go on. So, what is the only way to fix this? Well, you've got to assert it. So go over here and say where. This where applies to just this one part. Actually, it probably applies to this whole expression. I wonder if it does. I'm actually not sure if it applies to like an expression or to like a component within an expression. Anyway. If you, normally there's no ambiguity, but you just have parentheses around whatever you want to do. If you have like multiple expressions, you can just put parentheses around them, and the where applies to all of them. And in this case, whichever way works. So anyway, the where, I'm gonna have a proof val. I'm just gonna have a lemma, myvect rest arrest. So I'm just proving something about this rest. Now, what am I proving about it? I'm proving that this constraint holds. This n-1, even though it can totally be -1, according to what I say right here about it. No, it's not that. It's never actually -1. It's always fine. It's always greater than or equal to 0. So, extern proof function, lemma myvect rest, and I'll take a list of let's say some type and some int. If you say nat here, then you're creating a problem again. Like it'll try to make nat hold before it passes the rest of this. So just say int. I don't care what it is. My vector of a and an n. So of some length, which is not necessarily greater than or equal to 0. I'm going to say actually it is greater than or equal to 0. Bam, like that. So an extern proof function, which is just an assertion. It's greater than or equal to 0. That's it. So I do a proof val here. If this were tail recursive, this wouldn't make it not tail recursive. This doesn't exist at runtime. It just establishes that this rest is fine. It's fine. And you do that, yeah, no longer complaints. So that is the only way to fix this. You have to have a proof of assertion. So since it's something normally you wouldn't run into it, because you probably use like the built-in types of the language. But if you do have recursive structures like this, you got to remember to like when you build them manually, you've got to give the length or give all of the arguments, since ATS allows for what you said to be the case. It allows for what you said to be the case to be the case and not make sense. Since ATS does what you tell it to do, if what you told it to do is stupid, you can fix that by having assertions that say, okay, actually, I know that this is the case. Like if it's a constructor, then this is never -1 because there aren't any lists that are negative length. It's either going to be empty or it's going to be a constructor. It's going to be more conses. So you can use a proof val to fix that. And then later on, perhaps years later, when you discover that, wait a second, I could have said this is an int that's greater than zero. When you discover that, you can go back and you can remove the proof function. But it's the same. The code is exact. The compilation result is exactly the same. You just satisfy the constraint solver. So this is a way where ATS can help you detect something stupid, and yeah, and you might need to do stuff like this legitimately in the future. Except like ATS's internal standard library does this exact same thing on its implementation of length for list VT types. But maybe there's more that I'm not getting there. Maybe you actually do need this and it breaks down elsewhere. Anyway, that's it. We're not doing a video about Idris. We're doing a video about this instead. Have a nice day.